HyperUA is an innovative software product under active development by Projexsys Incorporated. In a nutshell, HyperUA provides a REST API on top of Opc Ua, allowing plain vanilla web clients to communicate with OPC backends. HyperUA leverages the strengths of HTML as an API and does not require its web clients to employ Java applets or Silverlight applications, or even JavaScript. In this demo, I'm going to provide a functional overview of how Opc Ua subscriptions, monitored items, and server-to-client notifications are translated into and encapsulated by HyperUA's REST API. First, we should briefly review the Opc Ua concepts just mentioned, namely subscriptions, monitored items, and notifications. Opc Ua client subscriptions are created and managed in the context of a client-server session, and are themselves the context for server-initiated data exchange and event notification. Subscriptions also provide a basic mechanism for client-server life pings, and they manage message grouping in order to make message delivery more efficient. Subscriptions aren't concerned with specific server-side data sources. That's the job of monitored items. A monitored item corresponds to a source of data in the server's address space, such as the value attribute of a variable node. Each monitored item has tunable characteristics that affect what kinds of notices are generated, how frequently messages are sent, and so on. Notifications are the individual messages sent from server to client. They contain data and timestamps, and they also indicate handles or IDs, which allow a client to determine to which subscription and monitored item each notification pertains. Here's the conceptual diagram from our introductory video, showing how HyperUA logically sits in between OPC applications and RESTful web clients. The mechanisms just described all pertain to the right-hand side of the diagram, where HyperUA acts as a true Opc Ua client to the OPC backends. HyperUA's job is to encapsulate those mechanisms so that its web clients can interact with them using RESTful resources, that is, simply by following web links, parsing HTML-based representations, and submitting forms. Let's do a quick run-through and see how it works in practice. By the way, this video is recorded in high definition, so you'll want to bump up your playback resolution using the YouTube controls if you haven't done so already. We have the same basic setup as seen in our other demo videos. KepServerEX is running on a virtual Windows server hosted in Dallas, Texas, and is providing an Opc Ua front-end to the classic batch reactor demo for Wonderware InTouch. Above that window, I'm connected to a terminal session running on a virtual Linux server in New York, in which a HyperUA server is running in the foreground. On the left, I've got a Chrome web browser running on my laptop in St. Louis, Missouri. I've already used the HyperUA REST API to establish a session with KepServer, and in the current page we see a representation of the reactor temperature node, which corresponds to this blinking box in the InTouch HMI. Notice the value attribute in the browser window. I'm going to manually refresh the page several times. Each refresh corresponds to a new GET request to HyperUA, and you'll notice the value attribute changing each time I do that. With Opc Ua, we can create a monitored item that will keep track of data change events for the reactor temperature node. The first step is to create an Opc Ua subscription, since monitored items are always associated with a particular subscription. We'll navigate back to the Kepware session item resource by opening its breadcrumb link in a new browser tab. Next, we'll navigate to the subscriptions collection for this particular item resource. It's empty since we haven't created any subscriptions yet, so let's create the first one. We'll navigate to the Create Subscription service call form and fill in some basic information. As I explained earlier, subscriptions and monitored items have several configurable parameters, but for this demo we'll stick with the defaults. After clicking Create, the browser is redirected to the subscription item resource we just created. Let's return to the Browser tab for the reactor temperature node. We'll follow the link to this node item resource's monitored items collection, and unsurprisingly, it's empty. Next, we'll navigate to the Create Monitored Item service call form, and we'll supply some basic information, including the ID for the subscription we created a moment ago. As with the subscription, we'll stick with the defaults for most of the parameters. In this demo, all of the monitored items I'll create pertain to the value attribute of variable nodes, and thus pertain specifically to data change events. HyperUA's full support of all event types is still a work in progress. After clicking Create, we're redirected to the monitored item resource. For convenience, monitored item resources are provided with HyperUA attributes, linking them back to their respective node and subscription. They also have a latest notification attribute. If I refresh this page, we'll see the value change from NA to a link to a subscription notification item resource. We'll come back to that, but for now, let's navigate to the subscription notifications collection for this monitored items resource. More than several notifications have already rolled in, as the temperature value is changing rapidly, and a link to the most recent notification is listed at the bottom. Let's follow that link and see what we get. The item resource for an individual notification provides some convenient links in its HyperUA attributes list, and the data from the OPC backend is in the list below. Jumping back to the monitored item resource, note again that the latest notification, that is, latest relative to the time of the web client's request, can always be accessed by following the link provided in the latest notification attribute. Let's jump back to the InTouch Demo folder node and find another variable node to monitor. For convenience, I've already got that folder node loaded in my first browser tab. I've pulled up the Opc Ua node corresponding to the product storage value in the HMI here on the right. I'll create a monitored item for this node too, but in a slightly different manner. First, I'll copy the node ID into my clipboard. Now I'm going to jump back to the Kepware session item resource using the link in the breadcrumbs. I'll follow the link to the subscriptions collection for this session item resource, and then the link to the one subscription resource we've already created. Then, I'll follow the link to that subscription item resource's monitored items collection. There's a link to the one monitored item resource we created earlier. We'll navigate to the Create Monitored Item service call form, except this time our context is the subscription rather than a particular node. I'll fill out the basic information, but this time I'll manually provide a node ID, that is, the ID for the product level node which we want to monitor. From this point, everything works as before, and I'm not going to focus on the notifications since they're really the simplest part of the picture. Instead, I'd like to take another look at the monitored items collection we've created so far, noting that each of those collections is logically distinct, as each pertains to a different context. The monitored items collection for the subscription indicates, naturally, all the monitored item resources for that subscription. Now let's navigate one by one to the two nodes we've chosen to monitor and review their respective monitored items collections. We'll use the node link provided in the HyperUA attributes for this purpose. Here's the monitored item resource for the reactor temperature node. Now we'll follow the link to the node itself, and now we'll jump to its monitored items collection. It contains one link since we've created one monitored item for that node. We'll quickly perform a similar navigation for the product level monitored item and node and see the same principle at work. We'll return once more to the monitored items collection for the subscription. My hope is that you're beginning to get a sense that HyperUA's various collection and item resources exhibit various degrees of very useful interconnectedness. Finally, I'd like to create a second subscription and a third monitored item which will be associated with it. This time, we'll monitor the reactor level node, and we'll set it up the same way as our first monitored item. I'll also be speeding up the video playback just to move things along. Now let's jump to the root of the HyperUA API. Note that it provides us with links to top-level collections, which include subscriptions, monitored items, and subscription notifications. The real point here is that the organizational principles behind HyperUA's API allow the various relationships between collection and item resources to be navigated and manipulated in different but complementary ways, providing added flexibility for applications built on top of HyperUA. An important point to take away from this hands-on demo is how HyperUA transforms several rather ephemeral runtime constructs into concrete addressable ones. In a traditional Opc Ua client-server application, sessions, subscriptions, monitored items, and notifications aren't generally treated as addressable resources. They don't correspond to nodes in a server's address space, and they aren't assigned URIs. That's not a weakness of Opc Ua, it's just the nature of how it's designed. But in order to make the leap to plain vanilla web connectivity, HyperUA extends and encapsulates those concepts so they are addressable, and does so in a manner that fully conforms to the REST architectural style. These elements of HyperUA's API are still under active development, and we're working on additional features. For example, it will be possible to search and sort notification items, configure how many are persisted to HyperUA's database and for how long, and we're still working on full coverage of the various standard Opc Ua service calls that pertain to subscriptions and monitored items. We're done with the hands-on part of this demo, but I'd like to address some elements of our future vision for HyperUA. In addition to HyperUA's REST API, Projexsys is actively developing a push notifications component, which will allow plain vanilla web clients using standard web technologies to subscribe to HyperUA sent notifications, which correspond to the notifications sent from OPC backends to a HyperUA server. What I'm about to describe is forward-looking, but a concrete demonstration will be provided in the near future. The basic premise is that continuous long-term polling of HyperUA resources is not efficient for a HyperUA server or its web clients, especially when the number of web clients grows large and/or those clients intend to monitor large quantities of resources. If web clients can effectively subscribe to a HyperUA resource and be pushed a notification upon change or event, only then re-requesting the resource, both CPU and network utilization will be more efficient for all endpoints of the application. This approach is also friendly to HTTP caches that are downstream from a HyperUA server, further increasing efficiency with respect to network resources. A few quick points about our approach, which again is under active development. The push service is entirely optional or opt-in, and clients that can't or don't wish to make use of it are not hampered in their use of HyperUA's REST API. In other words, web clients always have the option of using timed polling to monitor HyperUA resources with HTTP GET requests. As an optional service, it's only loosely coupled to the REST API, and is really an API and server in its own right. While the push API necessarily involves stateful web-based client-to-server communication, it represents an orthogonal set of concerns with respect to the REST API. Since it's a loosely coupled, logically separate, and optional service, it does not violate the constraints of the REST architecture. The push service is driven by a set of straightforward conventions which are not tied to a particular web client language or runtime. Thus, a wide variety of web clients should be able to implement the subscription mechanism, including JavaScript-powered web apps running in a browser, .NET or JVM-based programs with web connectivity, and so on. Multiple web transports are supported, further enhancing the diversity of web clients that may hook into the service. These transports include XHR long polling, JSON-P, WebSocket, and a few others. For this purpose, rather than reinventing the wheel, Projexsys is evaluating several popular open-source socket abstraction frameworks, including Sock.js and Socket.io, but we haven't made a final decision. The push service is also being designed so that it can hook into larger-scale notification systems, such as Apple's push notification service and Google's cloud messaging for Android. This concludes our demo and the preview of our forthcoming push service for HyperUA. Thank you for watching. We invite you to learn more about HyperUA and our vision for the future, and how your company can become a Projexsys OEM. Please visit our website and feel free to shoot us an email with any questions you may have. You can also find us on Twitter and Facebook.